for target 10A, I can describe the function of different types of registers. So moving on to the first task of this fixed demo, we were asked to create a 4-bit universal register that has 4 different modes. And here it is. And I will go ahead with these definitions. First one is a register. A register is just something that holds memory. A shift register is something that stores and shifts binary data, and it's made out of flip-flops with the output of one leading into the input of the next. And this is going to be loaded serially, as in every single bit is going to be shuffled either left or right, and then depending on the design of the circuit, it could be filled in, and it could also loop back around. Next is going to be parallel load. This is when all the data is stored into the register simultaneously, and for all of these definitions, I can demonstrate on this universal register. And then lastly is going to be our serial load, and this is when data is stored into a register 1 bit at a time. And then we can just go ahead with the modes. So right here we're in mode 3, which we're just loading. And for demonstrative purposes, here. And this is going to be our parallel load, as we were just mentioning previously. When I click the clock pulse, all of these inputs are going to go directly into these flip-flops and out in these outputs. And this is going to be simultaneous. Awesome. And then from here, we can demonstrate the other modes. So real quick, no change mode. We can do a couple clock pulses. Oh, nothing's even changing. 1 second. Let's change these inputs all to 0. All of these outputs are 1, and they are not changing. And then the next, we're going to shift right. And everything is moving to the least significant bit. So these were all 1s. Now we have a 0 here. Now we have 2 zeros. Everything's moving to the least significant bit. And we can demonstrate our serial in, as mentioned prior, or our serial load, as mentioned prior. So right here, our write in is going to go here. So this will be a 1, this will be a 0, this will be, this will be a 1, this will be a 0. 0, 1, we can keep going, 1, and now all of the outputs are 1. And then we can move on to the next mode, which is going to be shifting left. It's going to be moving to the most significant bit. Let's have a 0 for demonstrative purposes. So clock pulse, moving down, and then we can demonstrate the serial load. 1, 1, 1, 1. And now these are all 1s. And then moving on to the different components of this, a universal register is going to be made up of, well, this one specifically is good. These are all 4-to-1 multiplexers, and then these are all D flip-flops. So looking into our 4-to-1 multiplexer, and let me get out of this one so that I can change the values. So a multiplexer is going to go from 4 inputs, and then based on whatever mode is selected, it will spit out that output, the corresponding output. So here we have a 0, 0, and the decimal equivalent to 0, 0 is going to be 0. And we can change any of these, but it's not going to matter because that's not the mode that we're in. Demonstrating mode 1, demonstrating mode 2, and then last is going to be 3. Perfect. And then moving on to these flip-flops. These flip-flops are going to be our current state. Whatever value is going to be in that current state, and based on the mode, that those values can change. And it's going to be a little bit out of order because I did not know how to make this little diagram different, but S1 is going to correspond to S1 here, and then S0 is going to correspond to S0 up here, and these are going to be our modes, and all of these multiplexers are hooked up to these modes and these switches. And then all of these D variables represent the value for that given mode. So say that we are in mode 0, which is going to be no change. It's just going to give us whatever value is in the corresponding flip-flop. So for D0, it's going to be Q0. For multiplexer 1, it's going to be Q1. Multiplexer 2 is going to be Q2. Multiplexer 3 is going to be Q3. Moving on to, say, D1. D1, we're shifting right. So whatever is, so for this pair, it's going to be the next pair. So Q0 is going to be Q1. Q1 is going to be Q2. You can see that right here. Q2 is going to be Q3. And then once we get to here, we're going to need a new number to feed in. And that is where this serial write in is going to come into play. And then shifting left, it's going to be D2. So we're going to be moving the other direction now. So whatever's in here is going to be the next one. Whatever's in here is going to be the next one. And then here is going to be the same case, just for left. This is going to be our serial in input. And then last is going to be D3. So D3 is going to be where all of our inputs are, because because mode 3 is load, it's going to load all of these inputs in and will be stored into our flip-flops. Let me just check my checklist. Awesome. I think we're all done with part A of this demo.